Okay, the heat transfer rate per unit area Q to a body from a fluid in natural or gravitational convection is a function of the temperature difference delta T, gravity G, and body length L, and three fluid properties: the kinematic viscosity mu, the conductivity K, and thermal expansion coefficient beta. Rewrite in dimensionless form if it's known that G and beta appear only as a product G times B. Okay. طيب أول شيء first يعني you need. I know maybe you don't remember units. I will help you in this يعني in case I give you if you want. بس هلا in heat transfer you will remember all units. يعني in heat transfer chapter we revised these. But in case you have any property that is new for you, I will give you the unit. So don't worry about the unit. Okay. طيب so for example we have the heat transfer rate per unit area. Let me change هيدا 1 second. Okay, so you have first the heat transfer rate per unit area Q. So you know that heat rate is in watt. Per unit area, so watt per meter square. Okay, we have the temperature difference has unit of temperature. فهون we need a new dimension. The dimension is Kelvin. Okay, Kelvin او degrees etc. يعني هيدي اليونت dimension لها corresponding dimension هي تتا. يعني مثل ما بنقول for meter I consider dimension L. So for unit of meter or feet or inch, dimension is L. For unit of second, dimension is T. Okay. For unit of kilogram or slug, etc., dimension is M. And here, same thing, you need to add a dimension for temperature. So all you have to do is to say, I will consider for delta T, which has a unit of temperature, degrees or Kelvin. Okay. I need a dimension for it. هي حنسميها تت. Okay. So you have now you know that to transform watt per meter square into what is the dimension of watt per meter square, you need to go back to a definition of power. What is watt? What is joule per second. Okay, and what is joule? Energy. Energy is force times distance. Okay, so it's F times D. So Newton, if you want, Newton times meter. Okay, and we know already that Newton is mass. It's the unit of a force. It's mass times acceleration. Okay, so we have in unit, Newton can be converted to kilogram times meter per second square. Okay, so now if you multiply kilogram meter per second square times now meter تصير in joule, so بتصير kilogram meter square over a second square. Okay, and then you divide again by you divide by second, so بصير second cube. Okay, and since you want, this is what? This is in what? You have now, you need heat transfer per unit area, and you need to divide the unit of watt by meter square. So if you divide now by meter square will cancel out. So what do you have now? You have the unit of Q in your system is kilogram per second cube. So the dimension will be M over T cube. Okay, so that's why they said that for Q, the dimension is M over T cube. Okay. Now, as we said, delta T is a temperature difference. So it has a dimension of temperature, which we called theta. Now, G is the gravity. You know that the gravity has the same unit of acceleration. So in terms of dimensions, it's L over T squared. Okay. You have to consider the body length. The body length, of course, L. We have the kinematic viscosity, if you remember by definition. The kinematic viscosity is the dynamic viscosity over the density, rho. Okay? We already learned in class how to get the dimension of mu. You get it from the equation of shear. Tau equals mu del u by del y. Okay, you can get the unit of mu. And then you divide by rho. Rho is in kilogram per meter cube. So the dimension of rho is m over L cube. Okay, so you need to multiply. You just have to say, I take the dimension of mu and I multiply it by L cube over m. Then I get, okay, I get the dimension of mu, which is the kinematic viscosity from the dynamic one. Okay. Now, second step, you know that if you do, Ilna, what is mu? If you remember, it's m L minus 1, okay, T minus 1. This is for mu. Now, for the dynamic viscosity, divided by rho, multiply by L cube and divide by m, so times L cube over m. M will cancel out, okay? And you will get L cube times L minus 1, it's L square over T. So that's it, okay? Now, for the thermal expansion coefficient, beta, here, of course, I don't consider that you will remember the unit of beta. I will tell you what is the unit. The unit of beta is 1 over degrees or 1 over Kelvin. So that's why as a dimension, okay, as a dimension, it's 1 over theta, okay? It's 1 over theta. And finally, you still have the final property, which is the conductivity K. Okay, the conductivity K, to determine its unit, we need to go back to the definition of conduction. We have seen together, okay, that the conduction rate, okay, or the conduction rate per unit area, Q second. So let me write it here. Q second is minus K dt by dx, okay? So no need to know, to remember units. You can deduce the units just from the formulas, okay? We have together now, we have determined for a heat flux, which is in watt per meter square, the dimension is m over T cube. So this is m over T cube. Now we need to determine what is the dimension of K. So we'll need to, we put dimension of K times, we have dt over dx. So you have, in the numerator, you have temperature. So you have theta, dimension theta, okay, over dx, which has a dimension of length L. Okay, so now if you take L to the other side over theta, you can say that the dimension of K is just m times L over theta T cube. Okay, so this is how we determined the dimension of K. And from now on, Maria, it's exactly the same procedure that we learned before. And once you put the unit, the dimensions, okay, you can use pi group theorem. You can use, if you want, inspection method, okay, etc. To be able to find the groups. And from now on, it's exactly the same method developed before. So if you use any of these methods that we developed to get groups, you will find that you have here these groups, these three groups. Okay.
هون ال independent variables فينا اخد دلتا تي
Yes.
جي ال وكي مثلا.
انت you should يعني for example you said that you can take three you can take هلا هون مش بس you can take three independent Maria four. ليش four؟ لأنه now you have an additional dimension. يعني before we were starting by j equal to 3 لأنه we were working in LTM. Okay. But now since we have an additional dimension, يعني you start by trying to get 4 independent variables. Okay, because you have 4 dimensions LTM theta. If you are able to get to find 4, it's fine. If not, بيكون في, as we said before, بيكون في the dimensions are grouped in a repetitive pattern, which is not the case here. Okay, and here you can verify, for example, let's say how you can select your 4 variables. Let me okay, first you can say, if I consider, for example, delta t, it contains theta. I can try to have delta t contains theta only. I can take L, for example, containing L only. Okay, K is the only one containing M. Great. يعني now if I take with them G, which is containing T also, these 4 will be independent, of course. Okay. Why they will be independent? And already you have 3 variables containing only a dimension that is not present in the others. Okay.
Yes.
يعني you are not able to simplify these dimensions. Okay. So this is a possibility, for example. When you consider K صار في theta, but you can verify إنه these 4 will not form a group. Okay? You can verify this. So then once you get these 4 variables, okay, you can you can say I will form a group with Q and another group with beta and another group with mu. Okay, so I will get my 3 groups. Now, in the second question, okay, they told you that beta and delta t must appear together. And they forced you to have beta and delta t together because they said rewrite in dimensionless form if it's known that g and beta appear only as the product g beta, and they are not independent. يعني كأنه instead of having 2 independent variables here, G alone و beta alone, they are grouped together. يعني you have one variable G times beta صاروا grouped together. Okay, and they form one variable. If they form one variable, you will lose, يعني instead of saying I have n equal 7, n will be equal to 6. Okay, and then when you state what are your variables, you say G and beta, you group them. So what is the dimension of G times beta? It's L over T squared theta. Okay, and then you will have, instead of 3 groups, only 2, because you do 6 minus 4 equal to 2 groups, and you can verify then that these 2 will be joined together. Okay, and now you can say that the groups you can form are QL over K delta T. This is the same group, and when you combine these 2, you will get one group together because G and beta cannot appear independently. They become one variable. Okay.
Okay.
Anyway, try to do it now. And in case you have any additional question, we can tackle it next time.
اوكي next time كمان اونلاين الجمعة يعني.
Yes. Okay.
اوكي.
Bye.
دكتور
Yes.
التست شو صار فيه؟
Well, I will talk about it now together.
يلا دين اوكي. ميرسي.
Awesome.
باي.